Okay, welcome to screencast for the 2016 paper 2, question 8 in section B. So it gets stuck in here, but as I suppose I always say, you should always try pause this and give each part a go before I run through it with you. So this question 8, the table below shows the data gathered by a company on average water usage in homes. So you have different percentages there. Now, even without seeing anything else to do, first thing I do is work out what the difference is here. So take those four figures away from 100 and see what percentage is left. They've given a sample calculation, and you can compare that to the number of degrees. So I suppose the first thing, just part A, all it's asking for is find a percentage used for the other activity and write it in the table. So your sample calculation here would involve just the calculation 100 take away 30. I'll run through that here. So that's the 100 take away the four figures. You're left with 24%. Now the answers jumped up there from the marking scheme, but whatever. So move on to B. Okay, so saying a pie chart can be used to represent the data is going to be drawn by you. The size of the angle representing clothes washing on the pie is 46.8%. You were told that on the table. Complete the table below to show the remaining angles in the pie chart. Okay, so I always do here, with any conversion, if you know what 1% equals, then you know what 2% equals, etc., etc. So you can put your statement that, now what was it, 13%, so 13%, okay, equals your 46.8 degrees. Okay, so now if you want to find out what 1% equals, just using algebra here. You divide both sides by 13, and you end up with 1%. Now it goes to the answer here. You're going to end up with 1% equals 3.6 degrees. So then 2% equals twice that. 24% equals 24 times that, which is 86.4. 30% equals 30 times your figure here, which is 108, etc., etc. Okay, and then write them on the table. So it does say complete the table. I think there's, if I recall, there's a reduction of one step back in terms of marking for not doing it on the table. Okay, so that's part B, part 1. Now you have to do is draw the pie chart. So they give you the pie to work on. Okay, so do it in pencil. So if you do mess up, you can rub it out, whatever. So draw a pie chart to represent the data. Now it says label the sector corresponding to each activity and write the size of the angle. So the label is what the activity is, and the size of the angle is obviously what the size of the angle is. I remember this year there was a reduction. If you didn't do both those things, you lost marks. Okay, so be very careful to obey what they say. Use your protractor. So bring a protractor to the exam and a compass. Make sure you know how the protractor works. So lay it down. Okay. No, I don't have an image here, but pie charts are assumed knowledge. You lay your protractor down here, the guideline, and then you have the rest of it. Now, excuse the bad drawing. If, say, the first angle was going to be, just say 24. Okay, find where 24 is on the protractor, draw a line out to the edge. Okay, and then you can draw the two lines between these two things and onto the outside. Okay, that's that. The final answer there. Now I started with this 100. I've taken this from the marking scheme. Just looks prettier than what I can do, and that's that. Move on here to part C. So again, I'm assuming you're pausing between each go and just giving it a go. I think you're familiar with the question, but I'll go through it anyway. And John compiled a table showing the amount of water used in his own household over the course of a week. He recorded the number of litres required for each activity and the number of times each activity was undertaken. The data was shown below in the table below. So they give you one sample calculation. Okay, one bath, 80 litres times 3. Now I should be able to see if that's correct. Okay, so I check on my calculator. 3 8 24. So that figure is correct. So it tells you what you're doing. Okay, so 125 litres by 20, 6 litres per minute by 32 minutes, etc., etc. So that's pretty standard. Fill your table in, I would do a sample calculation down the bottom here. Okay, you don't have much space, but it's worth showing what you've done. Okay, and you're putting in the units you're using, so it's liters. So when you total all that up, you get the 3937. Okay, which is the ultimate answer you're looking for. Now, that's part C, part 2 now. If water were charged at 185 per 1,000 litres, find what John's household would pay for the water used in 1 year if the household uses the same amount of water each week. Now, he's using, 3937 litres per week. Now, let's be clear on this, and this is something that was answered by, I'd say, about 10% of students, maybe a little less. They're saying there was 48 weeks in a year. Just for clarity, there are 52. Okay, so 52 weeks in 1 year. You're basically multiplying your 3937 by 52 to find out the total number of litres in the year. You're then dividing that by 1,000, okay, to find out how many thousands are representing that number, and then multiplying that by 1.85. And there's different approaches to this, but the way I've done it here is I've multiplied the 3937 by 52 to get this figure, 204,724. Now if I divide that by 1,000, I'm moving the decimal place back 3 spaces. Okay, so I end up at 204.724, and multiply that by the 1.85, and I get 378 euros, 0.7394 cents. And they wanted rounded to the nearest cent, okay, which would be 378.74, because the 9 is greater than 5. The previous number goes up by 1. So that's part 2. Part 3 now, find John's total bill for this water if VAT would have been included at a rate of 13.5%. Okay, so what I've done here now, this is maybe a bit of a reach for some people, but I'm basically getting 378.74 by 13.5%, and adding that back onto the original. Now I can do that by multiplying my figure by 1, which will represent the 378.74, and the extra 13.5%, which is the same thing as 0.135. You can test this in your calculator by dividing 13.5 by 100, and you'll get the figure of 0.135. So that's multiplying by the original and the increase, and that gives me 429.869, which rounds back to, in cents, 0.87. Okay, and that's my answer. Now make sure with both these figures to put the euro symbol in. That's the unit we're talking about here. Okay, so let's see part 3. Now part D here, you're looking here, I suppose I have a comment here on the info box. This is pretty tricky, but we'll get stuck in. Again, I would pause it, try to give yourself a go and see how far you can get. John would like to reduce his water bill to 260 per year. Okay, so he obviously has to use less water. If water were charged at €1.85 plus VAT at 13.5% per 1,000 litres, find the number of litres of water he could purchase for 260. So you're basically trying to find out how much 1,000 litres of water would cost with VAT, then dividing that number into 260 to get how many 1,000 litres he can purchase. Okay, let's go through. I'm going to go through the answer because that makes more sense. So 1.85 by 1.135 gives you the total amount that 1,000 litre costs with VAT. So again, I've multiplied by the 1 to represent the 1.85 and the increase, the 0.135. Now you can, a lot of students round it here, and they've got a penalty for early rounding, because if you round that to 2.1, you're missing the 0.0035, or 25, sorry, or 35, whatever, they're missing that difference on the figure, which is going to have an effect on this answer. It's going to have an effect on the final answer. So keep this figure going. Okay, it's only 5 decimal places, and this is the same for any question, be it trigonometry. Rounding early or converting, something early will usually involve a penalty because your answer is not as accurate as it could potentially be. So I'm dividing the 260, the amount he wants to spend, by the amount of the cost of 1,000 litres. So he can basically use 223 thousandths of a liter. Okay, so if that to find out the actual number of liters, you multiply that by 1,000. So you move the decimal place 3 times to the right. Okay, or put it through your calculator. And the final answer, because they did ask you to find the number of liters, not the number of thousands of liters. And your final answer is 123,824 liters. And that's it. Okay, so just as a note here, just in terms of the marking scheme, that was worth 20 marks, that part. So any attempt there got 5 marks. The low partial is the lower grade of a question, depending on the actual question itself. So that any calculation really multiplying anything by anything would have got you the low partial. Now that's part D. So that's it. Okay, so again, have a go back over that in a few days' time. It's a good question. There's lots of stuff in there that's doable, but there are a lot of tricky things to do, percentages that often put people off. So thanks for listening.